Hello everyone. We are now in the final section of chapter 4, which was on systems of numeration. This particular section talks about early computational methods, and we will specifically look into some techniques of multiplication that was used long time ago, maybe several centuries back. They are not used any longer, but it's interesting to learn about them and understand how multiplication was done uh, in the past. All right. So let's look at three different techniques. We'll first talk about a method called duplicity and mediation, and then there is the lattice method of multiplication, and then finally Napier's rod. So we'll talk about three techniques of multiplication in this section. So again, we will learn the three different ways of multiplying whole numbers using duplicity and mediation, lattice multiplication, and Napier's rods. Again, the techniques that we will learn in this section are methods of multiplication used by the early civilizations, and the multiplication was performed by a method called duplicity and mediation. Duplicity implies doubling a value, and mediation implies halving a value. All right. And then there is the lattice method, which is also a very interesting method. And Napier's rods method is actually very similar to the lattice method. So we will start with the duplicity and mediation method. A little bit of a history. It is also known as the Russian peasant multiplication. As I said before, duplicity refers to doubling a number. So you will see in the process we will be doubling, that means multiplying by 2 a certain number, and the term mediation refers to halving a number, that means dividing the number by 2. All right, and uh, similar to ancient Egyptian method described in rind papyrus. So it goes back all the way to the Egyptian civilization, these two methods. It's not the exact method that the Egyptians used, but somewhat similar to it, right? Now, the way to perform the multiplication using the duplicity and mediation method is to write these two numbers, 25 and 31, with a dash in between them. So it says here multiply 25 times 31 using duplicity and mediation. So to begin the process, I'm going to write the two values like this, 25, and then put a dash in between them, and then write the number 31. All right, and this is a dash, not a minus. All right, and then we proceed by halving. All right, so this is 25. We are going to divide the 25 by 2 and write the quotient under it. As far as the number on the right side, 31, we are going to double this value and write the uh, write the uh, write the answer over here. All right, and we have to keep doing this until we end up with a 1 under the 25 or all the way. So again, keep in mind duplicity means doubling, so multiplying by 2, multiply by 2, and mediation means halving, all right, taking the half of the previous value. So that means dividing by 2. All right, so doubling is done on the value on the right hand side, halving is done to the value on the left hand side. All right, so 25, we have to halve it and write it as 25 divided by 2 is 12, but remainder is 1, correct? So we are going to ignore the remainder and just write 12. All right, so here we go. 25 divided by 2 is 12, remainder 1, correct? So we are going to ignore the remainder and just write this 12 underneath the 25. As far as the 31 is concerned, we have to double it. We have to double it. So 31 multiplied by 2 is 62. I'm going to write 62 and put the dash in between the two to keep it separate. And then we have to continue the process. So again, this time 12 divided by 2, which is a 6. All right, so let's write the 6 here. And for the 62, we are doubling it. So 62 times 2 is going to be 124. All right, so I'm going to write the 124 underneath this. And again, keep repeating the process until you end up with a 1 after halving, all right, on the left hand side. So 6 divided by 2 is a 3. I'm going to write the 3 here and then a dash. Now I have to double 124. 124 times 2 is 248. So let's write the 248. And then 3 divided by 2 again. So here we did 12 divided by 2 and we got a 6. Then we did 6 divided by 2, we got a 3. Now we are going to do 3 divided by 2 and the quotient is going to be a 1. This is going to give us a remainder of 1, but like we said before, you can ignore the remainder. You have to ignore the remainder rather. So the quotient is a 1. And then with the dash, we have to double 248 and the value we get is 496. All right. Now, the next step and the next step rather, not quite the final step, but the next step is to look at the values on the left hand side and cross out all the even values and its partner here. So 12 is an even value. You have to cross that out, cancel that out, including the 62 that goes with it. So here I go. I'm going to cross. This is even. So you cross out all the even values. 6 is an even value. I'm going to cross this out. 3 is not even. So that stays. 1 is odd. That stays. And 25, which is the initial value, all right, that we are multiplying, that also stays because it is odd. It's not even. So you only cross out the even values, and then what you do is you sum up, all right, you add the values on the right hand side. So what I'm going to do, I'm going to take 31, 248 and 496 and add them up, and when we do the addition we should come up with, this is 5, 8 plus 6, 14, 5, 15, 1, and then we will have 7, 6, 7. So the answer is 775. So 25 times 31 equals 775 using the duplication and mediation method, and it should be the same answer if you do the multiplication in the traditional way, all right, that we know, that we had learned. You should still get 775. So 5 times 1 is 5, 2 times 1 is 2, and 5 times 3 is 15. 3 2s are 6 plus 1 7 for a value of 775, and that matches with what we got here using the duplication and mediation method. All right, so I'm going to pull up the solution now, and the PowerPoint has worked this through several slides step by step. I did everything in one go to give you a to give you an introduction of what we are going to see next. So I'm going to go ahead and uh, erase some of this information. Sorry. Let me first erase this before the solutions come up. Otherwise, we won't be able to read what comes up. So just give me a little bit of time here to do the erasing. Okay, so here it says the first step is to write 25 and 31 with a dash between the two numbers, which we did. All right, and then let's see what it says next. So 25 dash 31 is how they wrote it. And then it says divide the number on the left by 2. Drop the remainder and place the quotient 12 under the 25. So that's what we did. So this got erased, but we divided 25 by 2. The number on the left is the 25. You have to divide only the values on the left by 2, which we did here. Drop the remainder. We did that too. We ignored the 1, which was the remainder after dividing 25 by 2. And we wrote the quotient 12 over here, right? And then in the next step, which will be appear on the other slide, all right, you have to double the value on the right hand side. So 31 multiplied by 2 is a 62. All right, so let's see how they work through this in the next couple of slides. So here they double the number on the right, 31, to obtain 62 and place it under the 31, right? So 25-31, when they divided the number value on the left hand side, they got a 12. When they doubled the number on the right hand side, 31 times 2 is 62. So continue this process until 1 appears in the left hand column. So after having and doubling all the values on the left hand side and the right hand side, right? Again, to repeat, we have all the values on the left hand side, ignore the remainder. On the right hand side values, we are multiplying by 2. So 12 divided by 2 is a 6, and 62 multiplied by 2 is 124. In the next step, 6 divided by 2 is a 3. 124 multiplied by 2 is 248. And then finally, 3 divided by 2 is 1 for the quotient. We get a remainder of 1, but we ignore the remainder. And 248 multiplied by 2 is 496. So what do we do in the next step? We cross out all the even numbers in the left-hand column and the corresponding numbers in the right-hand column. So 12 is an even value, 6 is an even value, and these are the only ones. And you have to start from the left-hand side. You're crossing out the values on the left hand side along with their corresponding right hand side values. So this will get crossed out, this will get crossed out, and we will end up adding the values remaining on the right hand side. So it'll be 31 plus 248 plus 496, which should give us a value of 775. All right, so that is the process, but they're going to show this last part in the next slide. So let's look at that. So you see here how they have crossed out the even numbers from the left hand side along with their corresponding right hand value. So 1262 goes away, 6124 goes away. We are left with 31. So 25, 3, 1 on the left hand side, 31, 248 and 496. But we add the remaining numbers in the right hand column. You don't have to do anything with the remaining values on the left hand side. All right, you only add the values on the right hand side, and that will give you the final answer of the multiplication. Okay. Another kind of multiplication is called the lattice multiplication. This is a grid-based system of multiplication, also referred to as the gelosia method. The gelosia method, or rather the word gelosia, is an Italian word to describe the lattice work or the grid work, which is often found in the on the windows of the buildings of Italy. Now, this is a grid-based system, and we construct a grid. We begin by constructing a grid which will be a matrix, which will be in the form of a matrix. And how big that matrix is going to be will be determined by the digits, the number of digits we are multiplying. All right. So, for example, let's say we are multiplying 314 with 27. So 314 is a number with 3 digits, and 27 is a number with 2 digits. So the grid is going to be a 3 by 2 matrix. That means 3 by 2 means it's going to have 6 cells in it. So we start the multiplication process with a rectangle here, right? A rectangle, and there will be three columns in the rectangle for each of the 3 digits in the first numeral, and then 2 digits will be the rows of the matrix. All right, so I'm going to write 314 as columns, as 3 different columns in the grid, in the matrix, and 27 are going to be the 2 rows written on the right hand side. So let's go through the process of how we perform this multiplication. So let's go through the process of lattice multiplication using this example of multiplying 312 by 75. All right, so we begin by drawing a matrix, which is in the form of a rectangle in most cases, and the size of the rectangle or the size of the matrix will be determined by the digits of the numerals that we are multiplying. So 312 has 3 digits in it, right? It has 3 digits, and 75 has 2 digits. So 3 times 2 is 6. So we will have our rectangle divided into 6 cells. All right, 6 cells with 3 columns and 2 rows. All right, so let's see over here, we have the rectangle divided into 3 columns, 1, 2, 3, and 2 rows, right? 1, 2. We are going to write the digits of the 3 digits of the first numeral as columns, right? So I'm going to write here 3, 1, and 2. The digits of the second numeral, 75, are going to be placed as rows. So it's going to be 7 for the first row and 5 for the row below. Next, what we do is we divide each cell into 2 parts by drawing a diagonal in each cell going from the left to the right. So what happens is each cell gets partitioned into 2 parts, and each of these parts are going to hold the digits of the multiplications we are going to perform. All right, so we do that for each and every cell that you see they have drawn diagonals across each cell to split each cell into 2 equal parts. And once we complete that, now it looks more like a lattice. We will start the process of multiplication. We start multiplying 3 by 7. So 3 times 7 is 21, correct? So what we do is we place the 2 of the 21 in the first on the top part of the first cell, and the 1 in the second in the partition below. All right, so 21, you write it 2, you separate the digits and put the first digit on the top part of the cell for 3. So 3, well, of the cell for 3 and 7, and write the 2 on top and 1 below. The next one is 1 times 7. So 1 times 7 is 7. Now 7 is a single digit value, but we still have to write it as 2 digits. So the digit to the left will be a 0. So we are going to write 0, 7. Let's do that. This is going to be a 0 and the 7 comes below. Then we have 2 times 7 is 14. 1 and 4. Next, we go to the second row, continue the process. 3 times 5 is 15. So 1, 5. 1 and 5. Next is 1 times 5 is 5. Again, it's a single digit value, but we have to write a 0 on the top cell, a 0 on the top partition of the cell, and 5 below. And finally, 2 times 5 is 10. We write it as 1, 0. All right, now we've completed all the multiplications. We will have to perform the addition now. All right, so the way we go about adding is, let me just pick another color. This is how we add. We add diagonally. So this is one diagonal. This is a diagonal. This is a diagonal. This is a diagonal. And this is the last diagonal on top. And we proceed from the left. We proceed from the right to the left. All right, because we will also need to carry over at times. So the addition is done just the way we add in multiplication in the traditional system. All right, so we'll start with 0. This is only one digit in this diagonal, so I'm going to write here 0. All right, it's going to be 0. Next, we move to the diagonal to the left. So 5 plus 1, 6, plus 4 is 10. So there's a carryover there. I'm going to write the 0 here and carry over the 1. I'll write the 1 somewhere here. All right, and then add 5 plus 7, 12, plus 1, 13, plus 1, 14, right? So 14, we write the 4 here, and the 1 gets carried over here maybe. Let me write it here, and then we continue. 1 plus 1 plus 1 is a 3, no carryover there, so 3, and then the last one on top is a 2, correct? It's a 2. So the final answer is going to be obtained by combining the digits like this over here. All right, we pick the digits 2, 3, 4, 0, 0. All right, so the final answer is going to be the answer for multiplying 312 times 75 is going to be 23400. Now I'm going to quickly perform the same multiplication using the method that we know traditionally, we've learned traditionally. And let's see if we get the same answer. 5 times 2 is a 10. 5 ones are 5, plus 1, 6. 5 threes are 15. So 312 times 5 is 1560. And then we start the multiplication with 7. 7 times 2, 14. 7 ones are 7, 8. 7 threes are 21. So we get 0, 6 plus 4, 10, carry over 1. 8 plus 5 is 13 plus 1, 14. There's a carry over here, 14. Carry over 3. 1 plus 1 plus 1 is a 3. 2, 3, 4, 0. And that exactly matches with what we got using the lattice method of multiplication. Now let's go over the same multiplication through the solutions that they have provided in this slide here. So the first step of the solution says construct a rectangle consisting of 3 columns and 2 rows. So 3 columns for these 3 digits in the first numeral of the multiplication, and 2 rows for the 2 digits for this numeral. Place the 3, 1, 2 above the boxes, that means the columns of the matrix. Place 75 on the right of the boxes, which will represent the rows. And that's exactly what we had done when we worked through this problem using the lattice method previously. Place a diagonal in each box or each cell to partition it into 2 equal parts. So in other words, here we go. Again, one more time, we construct a rectangle with 3 columns. So let's divide this into 3 columns and 2 rows, and place the 3, 1, 2, the digits of the first number, above the boxes. So it's going to have 3, 1, and 2. Place 75 on the right of the boxes. So 7 and 5, that will represent the rows. And then we have to divide each cell, each individual rectangle, into 2 parts by drawing a diagonal. So let's do that here. Each of these boxes will be further divided into 2 or partitioned into 2 with a diagonal from the left to the right. So again, this is the picture of the matrix that we just constructed. Now we will start the process of multiplication. So let's go over the process, or rather review the process. We've already gone over it once, but think of it as a review, and let's see what the steps are and how they perform the multiplication. So let's go through the process of multiplication. I've pre-drawn a matrix here just the way they had asked us to. It says here, as the next step, complete each box by multiplying the number on the top of the box by the number on the right of the box. So 3 times 7 is what we are going to do. All right, so let's see what they say next. It says place the units digit of the product below the diagonal and place the tens digit of the product above the diagonal. So 3 times 7 is 21. So it's 21. However, the 1, which is the units part of the number, should be placed below the diagonal. So it's going to be like this. It's going to be 1, and the 2 is going to go on top. All right, the tens value is going to go, the tens digit is going to go on top, on the top portion of the diagonal. So let's continue this. 3 times 7 is 21. We already completed that. 1 times 7, all right, is 7, so 0, 7, 14, and then we have 3 times 5, 15. We have 1 times 5, 0, 5, and 2 times 5, 10. All right, so that's how we complete filling in all the partitions of the matrix. So let's see the values fill up. 3, 7, that multiplication is being done first. 3 times 7, 21. We place the units value in the part below and the tens value in the part above, right? And then 1 times 7 should be written as 0, 7, and then 2 times 7 should be written as 1, 4. Now we go to the row below. 3 times 5, 15, 1, 5. 1 times 5, 0, 5. And finally, 2 times 5 is 10, so 1, 0. Right? Now here we perform the part of adding the diagonals. Right? So let's see here. The first diagonal, we start from the bottom right. First diagonal is a 0. Then the second diagonal from the to the left is added. So 5 plus 1, 6 plus 4, 10. So we write the 0 here and carry over the 1 to the next diagonal to the left. Right? So let's see what comes up. 7 plus 1, 8 plus 5, 13 plus 1 that we carried over. Right? We carried over from here. That 1 makes it 14. So we write the 4 here and carry over the 1 to the next diagonal to the left. So 1 plus 1 plus 1 from the carryover should give us a 3. And then finally, it's a 2 for the last diagonal on top. All right. And then what do? We go to the next one where we pick up the values. Right? We pick up the values 2, 3, 4, 0, 0, and that would be the answer. We read the answer down the left-hand column and along the bottom. The left-hand column and along the bottom. So that completes the lattice multiplication process. All right. Therefore, 312 times 75 is 23,400. Okay. Now we learn about Napier's rods. John Napier was an early mathematician who made a lot of contribution in the field of mathematics. He developed the method called of multiplication using Napier's rods way back in the 600s. Napier's rods proved to be one of the forerunners of the modern day computer. So even though these are outdated methods of multiplication, they still find application in today's world of mathematics, right? Now, I'm going to just read through this slide essentially because it won't make much sense unless you see a picture of how Napier's rods are arranged. But this gives a description of what to expect. So the next slide will have a table, a picture of Napier's rods, but let's read through it first and get some idea what it's supposed to look like. So it says here Napier developed a system of separate rods numbered 0 through 9 and an additional rod for an index numbered vertically 1 through 9. So what you can expect to see in Napier's rods, the diagram, you will see a top column starting from 0 and then 1, 2, 3, 4, 5, 6, 7, 8 all the way up to 9. a cross on the top row and then what's called an additional rod for an index. So that index will be numbered vertically starting from 1 instead of 0. So on the left hand column, in the extreme left hand column, you will see numbers 1, 2, 3, 4, 5 vertically coming down. So it's going to form a matrix, so to speak, and inside there are going to be values, all right, columns with diagonals in it. So it says here each rod is divided into 10 blocks. Each block below the first contains a multiple of the number in the first block. So each of these blocks, just like we saw in the previous method that we learned about in the lattice method, each of these blocks are going to be divided by a diagonal, and they are going to hold the digits resulting from a multiplication. So each block below the first contains a multiple of the number in the first block with a diagonal separating its digits. All right, so you will see diagonals, and then units digits are placed to the right of the diagonals, right or to the bottom part of the diagonal, so to speak, and the tens digits, all right, if it has 2 digits, then the tens digits to the left, that or the upper part of the diagonal. All right, so let's go into the next slide and look at a picture of what the Napier's rods look like. So here's a picture of the table that Napier came up with, also called Napier's rod. So again, across we see on the top column, we see values listed from 0 through 9. And then on the leftmost column, separately, we have what's called the index, and the index values start from 1 all the way to 9. No 0 in the index column, 1 through 9. And each of these columns have blocks, so squares, all right, and each of the squares are divided by a diagonal, all right, they are divided by a diagonal, and the values in the diagonal are what we obtain by multiplying the index value with the column value on top. So 1 times 0 is 0. So 0 is represented as two digits here. So 0 and 0. So 1 0 goes on top of the diagonal and the other one goes at the bottom. Likewise, 2 times 0 is also 0. So we have 0 and 0 above and below the diagonal. So all these index values when multiplied by 0 will have an answer of 0, correct? So that's why you see zeros all through the first column. Then the next column has 1, and 1 multiplied by 1 is 1. So we always write it as a 2-digit value, even though it's a 1-digit number, but we write it as 2-digit values as 0, 1, and the left digit goes above and the right digit goes below the diagonal. All right, so 1 times 1 is 1, so 0, 1. 2 times 1 is 2, so therefore 0, 2. 7 times 1 is 7, so 0, 7. Then the next column has 2. So 2 times 1 is 2. So 0, 2. Let's pick another number. 6 times 2 should be 12. So 1, 2. All right. So that's how it goes all the way through to 9. So 9 times 9 is 81. So we should have 8 and 1. 8 above and 1 below the diagonal. All right. So that's how Napier's rods looks like. So we will have to see how to use this table to perform a multiplication. All right. Now let's go over an example of multiplying two values using Napier's rod. All right. So we are multiplying here 2 and 3-digit numbers. So 48 is the 2-digit number and 365 is the 3-digit numbers. But if you recall, Napier's rods had values which were single digits across the first top row, right? And then the index also had single digit values from 1 through 9. So across on the top row, the columns had values from 0 to 9, whereas the index, which was the leftmost column, separated, that had values from 1 through 9. But here we have 2 and 3-digit values. So how do we go about doing the multiplication? Somehow we have to get that 48 and get it to a single digit, all right, without really changing the value. So let's go through the process step by step. All right. So the first step here, it says 48 times 365. So what they did was they broke up 48 and wrote it as 40 plus 8 times 365. All right. We are trying to get the multiplication done using a single digit, but without really changing the multiplication, the numbers. All right, so there's a strategy to that. So first step is we take that 48 and we write it in expanded form as 40 plus 8. So let's see what we do in the next step. In the next step, we have 40 plus 8 times 365, and we use the distribution property that of multiplication. All right, so it's the same as saying 40 multiplied by 365 and 8 multiplied by 365. If you recall from algebra, there was a distribution property. So if you have two values, all right, addition or subtraction within brackets, then you have to distribute the value outside and write it as 40 times 365 for this example plus 8 times 365. Now what happens next? To find 40 times 365, we just determine 4 times 365 and then we'll multiply the result by 10. All right, so it says to find 40 times 365, determine 4 times 365, and whatever that value is comes out to be the product will get multiplied by 10 to get back our 40 times 365. And then finally, to evaluate 4 times 365, we will set up Napier's rods for 3, 6, and 5 with the index 4. All right, so that is how we turn this to a single digit multiplication, and we'll break up 3, 6, 5, right, as separate digits and perform the multiplication. So let's go to the next slide to see what the process is after this. Now at this point, we do not need the entire Napier's rod table. We can only pick the columns 3, 6, and 5, and for the index only 4, and do the multiplication. So 4 times 3 is 12. So we write the 1 on the top above the diagonal and 2 below the diagonal. All right, and then 4 times 6, 24. 2 goes above and 4 goes below, and 4 times 5 is 20. So 2 goes above and 0 goes below. All right, so now we have to add the values diagonally, right? So let's bring that up. So we have first 0. This part is 0, nothing to add here. Then we have 4 plus 2. All right, we will end up adding 4 and 2, this diagonal. So 4 plus 2 is 6. Next will be 2 plus 2. Let's pull that up. 2 plus 2 is a 4, and then we will have the 1, again a single value here, so that will be a 1. All right, and therefore the end result will be 1 4 6 0. All right, so 1, we pick the 1 and then go down across the bottom row and pick up 4 6 and 0. Okay, so 4 times 365 gives us 1460 for the answer. Now we will have to remember we dropped the 40 and changed it to a 4 to get a single digit, but now to get back the 40 we have to multiply 1460 by the 10. So we'll do that in the next. Now we will be continuing the process and completing it on this slide. So over here we have 40 times 365. Now the calculation we did in the previous slide using Napier's rod was 4 times 365 because we needed single digits, multiplication by single digits to use the process of Napier's rods, right? So we had to drop the 40, the 0, next to the 4, and we ended up multiplying 4 times 365. But now we have to bring back the 0. So what we do is we multiply the result that we got from 4 times 365. We have to multiply that by 10 and we get a value of 14,600. All right. Now in the next step, remember the initial calculation, we were trying to multiply 48 times 365 and we had broken it up into 40 times 365 plus 8 times 365. So we've completed the part which is 40 times 365 and we got a result of 14,600. However, we did not yet complete the multiplication for 8 times 365, and for that we again have to go back to the Napier's table and do the calculation. They haven't shown the work for this one, but now we know how to use the table to perform the multiplication. So when they complete the multiplication, we get 14,600 for 40 times 365 and 2,920 for 8 times 365. And now that we got both the results from the multiplications, we just add the two up for a final answer of 17,520. All right, so that's how we perform different multiplications using the Napier's rod system. Okay.